All right, so problem number 1 says sketch dot plots for each small set of data. What shape would it describe? So number 1A. So if I was to do a dot plot, 5, 6, 7, 8, and 9. All right, so I have a dot here. I have 3 of these. I have 1, 2, 3. 3 of these. I have 2 6s. I have a 7, an 8, and a 9. Okay, so if we were to try and make some sort of smooth curve, this way is our tail. Agree? So this is skew right or skew positive. Okay? For letter B, and we're just on 111, 112 going through it because I never went through it. So that's all we're going to do today. So I got 2, 3, 4, 5. 2, 3, 4, 5. I have 1, 2, 3. 1, 2, 3. I have 1, 2, 3. I have 1, 2, 3. 1, 2, 3. This one is just rectangular because it looks like a rectangle, right? If you were to draw a shape to it, you really can't. It's just a rectangle. Everything is the same data. May I move off this slide?
Give me 1 second.
1001. Moving. Okay. Good. All right. Letter C. What? 111. Letter C. We have 2 through 7. So 2, 3, 4, 5, 6, 7.
What was it? A? What was it? Skew what?
Skew right. The tail was more to the right. All right, so I got a 2, hey, and a 1, 2, hey, and a 1, 2, 3, 4, 1, 2, 3, 4, and a 5, 1, 2, 3, 4, 5. B is rectangular. Oh, I love the conversation. So if I draw this, I think you would be safe if you said you could easily argue that it could be bimodal because I have 4 and 5 the exact same amount of times. I think that's a really good thing to realize. But it also, when you look at it, it also looks like it's a normal distribution. It's not skewed right or left. So it becomes your choice, and I think both are correct answers. Okay? So I would say list one or the other. If it was a multiple choice, if this was a multiple choice question, then you could pick one or both. I would accept one, bimodal or normal, or if we circle both, I'd say, hey, cool. Okay? Especially because we're using technology with this stuff. Letter D, I have 3, 4, 5, 6, 7, 8, 9, and 10. All right, 3, there's 1. There's no for 4. There's 1 for 5. 6, there's 1. 7, there's 2. 3 on 8.
What was A?
Skew right. 2. Uh-oh. Yeah, why do you think it's skew left? I absolutely... Yeah, we have the long tail over here, so this is skew left or skew negative. Okay, we're going to stick with the skew left, so. Okay. And then letter E. 1, 2, 3, 4, 5, 6. 4, 5, 6. Oh, we're now safe because the door's armed. 1, 1, 2, 3. 1, 2, 3. 1, 2. All right. So this is one I think you could easily argue could be normal, but because 3 and 4 you have the same amount there, it also could be bimodal. I think that's to argue. A true normal curve would be, let's say you had this 3.5 in the middle, and you had 4 dots there, something like that. So then it becomes like you have a symmetry point for the most part. Basically, the more data you get, like these only have that much data. They have just a couple of things. Hey, good to see you. We're on page 111, 112, just going through it because I never did. So the problem with stats, sometimes when you're looking at a small amount of stats, there's not really enough stats to make a conclusion based off of, other than you can make observations. But let's say if I had 100,000 dots that I plotted, if you only plotted 10 dots, it might start looking bimodal. If you plotted the 100,000 dots of all the data points, the bimodal probably would go away. Okay, but we just have a limited amount. Number 2 says create a data set or dot plot that demonstrates bimodal distribution. Okay, so this could be bimodal. So this could be an obvious bimodal where this and this creates your 2 modes. So basically it would do something like that, which is goofy. But again, if you created more and more data that you plotted on this, the more and more it could approach to be a normal curve. Number 3, study each situation, decide which shape each data is likely to form. And bless you. The number of runs scored each game by a baseball team. Well, if we were talking about an entire season, I would say you have more scores closer to 0 than you would have closer to 100. Okay? I mean, if you score 100 points or 100 runs in a baseball game, it's unbelievable. So I think 3A, I think you could argue it would be skew left. Okay? Because you'd have, well, no, take it back. Skew right. Because you might have scores of 0, 1, 2, and 3 a lot more often than the guy who scored 17 against you. Okay, that would be skew right. Letter B, the high temperature each summer day in Denver. I would say, let's see, like this summer we had 4,000 days of rain at the beginning of the summer, right? So it was really cool. It didn't feel like summer for a long time. So like this summer, I would say you had some low temperatures, and now we've had, obviously yesterday was beautiful, but we've had some pretty high temperatures. So I think that could be a skew left for this summer, but it might be different next summer. A, I would say skew left. Right? Is that what you said?
Skew right.
Skew right. I'm sorry. Skew right for the A, high temperature in the summer. Yeah, I think you could argue either anyway on that one because it depends upon what year you're dealing with. Yeah.
I feel like if you depend, let's say 0 to 7 runs or something like that, you could but it's up to debate how far you measure it and
so
playing what kind of team.
I agree. If you're using a histogram, I agree wholeheartly. But if I was using a dot plot, so I'd have 0, 1, 2, 3, all the way up, and then you have how many times you scored only once, twice, how many times. So the dot plot would maintain the data set. But on a histogram, you're absolutely right. You'd have a range. So from 0 to 7, from 7 to 14, so on and so forth. That might have a little bit different shape. But I like your thought. It's good stuff. 3C, the last digit of a social security number. So your last digit of social security number could be 0 through 9. There's no rhyme or reason. There should be about the same amount of zeros as there are 9s in every other number. So I'd say that's probably rectangular. Okay. And then number 4 on page 112 says, assume that the data set has a mean of 6 and a median of 4. Okay, so now we're starting to get into the meat and potatoes of this. All right, so we have a mean of 6 and a median, which is Q2, of 4. So I want you to think about this. if I had some sort of curve, and I had X bar here, oh, there it goes. So if I drew it as normal, but if the mean is greater than the median, remember the mean is pulled to the skew. So the mean is 6. The mean is being pulled to the right. So this first one for number 4 is skew right. Number 5 says assume the data set has a mean of 60 and a median of 60. There's no skew to that. Okay, it's symmetric. You can say it's a normal distribution. We haven't really got to that yet, but there's no skewness in that situation. If we do the mean and the median are the exact same. Number 6 says sometimes data sets are hard to describe. Can a data set have a characteristic of both bimodal and skew right distribution? Absolutely. Okay. So you could have 2 humps in there, and you could have a really long tail off to the right or to the left. So you could have both that could take place. And then, all right, so the data is provided in there. So let's jump on to our new best friend, the Desmos family. Well, I can still use it. One of these days they're going to charge me, $10 a year. All right. So Desmos Lachita. So, and I got to tell you, I was very impressed. Y'all were really doing well with the Desmos yesterday. I mean, your questions are becoming fewer and fewer, which I really appreciate. I mean, that means that tells me you are comprehending what we're doing on Desmos, and I love it. So congratulations, my friends. 36, 28, 34, 72. Oh, look who showed. We're on page 112.
Perfect.
Don't leave me hanging. And you got a quiz to make up with me, okay?
Yes, I can do it later.
Oh, you're making promises you won't keep.
Oh, I can do it sometime.
I'm just kidding. Giving you a hard time, you know that. 65 and 40. All right. Create the appropriate display. What type of display? Well, because I had all this data, I mean, we could have probably done a stem plot, but I'm sticking with the one that we seem friendly with. So I think a histogram looks pretty good. Okay, we could change that the widths to see if we get, hey, that actually looks pretty good. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 things there. I made it 6 wide. What shape does that appear to be?
Right.
Skew right. So the mean is to the right of the median. The mean is to the right of the middle of our data. Okay, but take a look. If we went back to this one, you could maybe get the argument there if you went with 4. So sometimes you just kind of have to go through and see which one is going to produce the picture. Yeah, that picture looks okay as well. 8. Okay, any of these seem to be showing skew right, so you kind of have to just play around with it, see which one's going to give you something that you can verbally talk about. Describe the data in terms of center and spread and outliers. Okay, we don't really know what an outlier is yet. It might be that the big number out there, that 72, I think was the biggest number in there. But our shape appears to be skew right. This means that our mean is bigger than is a larger number than our median. So those are things that you could probably say. What do you anticipate the relationship between the median and the median? Well, we just said the mean is to the right of the median. Okay, that means the mean is in the direction of its skewness. And then it says calculate the standard deviation. Okay, standard deviation, STDEV. L, standard deviation, 12.7 or 12.72. So again, yeah, we could work the standard deviation out by hand and y'all would hate me. Or I could show you how to quick do it and say, hey, yeah, there is this ugly looking equation. Desmos is a good friend of ours, so we're going to keep him around. All right. So, so again, our quiz scores are in. Please come to me on one of your off periods. If it's not my same off period, come towards the end of your off period. Does that make sense? And I'm happy to let you get half your points back. If you owe me, you need to finish a quiz. Let's get it done sooner than later, please. And is anyone going to be upset if I didn't have an assignment for tonight?
No.
Okay, I'm not getting emails from parents. Okay. So tomorrow we'll do 1-9, a lecture on that. And then, was that? Well, we're good. We went through it. We feel solid.